Thank you for the introduction. Hi, everyone. I'd like to formally welcome you to my presentation. So I'll begin by saying a big thank you to every one of you for coming to listen to me speak. It means so much to me. And I hope at the end of this session, you take away something reasonable or you get insight on the importance of building fair machine learning models for everyone and some tricks or some points that can help you build better machine learning models. She has given much of an introduction about me. So this is who I am. I'm Elizabeth. I do business analysis currently with Carbon Notes AI. And I'm just rounding off my MSc in Applied AI and Data Analytics at the University of Bradford. I should complete my MSc in June. I founded PyData Bradford Meetup, and I currently organize with some beautiful people seated in this room currently. Yeah, so I hope you enjoy this talk. Thank you. Now, I'd like to start with this thought-provoking question: AI for everyone, a reality or a dream? So I need you to ask yourself that question. We've seen AI bring groundbreaking solutions. We've seen AI in medicine, AI in finance, AI in everywhere, even your LLMs that help you become more creative and go by your day-to-day activities better. But then the issue comes when models are kind to people, to some set of people, and not very nice to some set of people. So I ask myself, do we think it comes to a time where AI is really fair for everyone? Or do you think it becomes a cycle where at this point you feel it's fair and another point it becomes unfair? Because we know humans are changing, humans evolve. I can wake up and feel this way about myself today, and tomorrow I wake up feeling another way about myself. So the question is, do you think it's a reality? Do you think it's achievable? But the major takeaway is, I think it is important. It is something that should be considered at every point. So we'll start by checking out some case studies of where bias has happened. First is the Apple's credit card scandal that happened in 2019 in the United States of America. So at that point, Apple launched a credit card system in partnership with Goldman Sachs. And when people started to apply for credit, they began to notice that the women had lesser credit than men. Even one of the journalists that worked on this case stated that even though he had similar credit score with his wife, he was offered a credit amount that was 20 times the amount his wife was offered. And that brings the question to why bias. Then we'll look at this case study again that was published in 2019, which is in the healthcare. We all know how healthcare is a very, very crucial part of humanity that shouldn't be joked with and we shouldn't take chances with. So in this particular case, they found out that people of color had less access to immediate care than other people. So if you apply for healthcare solution, your insurance company and your healthcare providers with their algorithm decide who should get better healthcare opportunities. And they discovered that people of color were deemed more healthy than white people, and that way they had less access to healthcare opportunities. In fact, it was confirmed that on average, they spent $1,800 less on Black people than white people. And at that point, the excuse was, oh, with the whole algorithm training, they feel Black people are healthier, which was very false because at that time, they had higher cases of kidney failures, heart issues, liver issues among Black people. So this is just a clear case of where a bias that has been fed into the system has actually directly impacted the lives of people. So it just makes me begin to wonder, because for me, I'm a passionate person about responsible AI. I hope sometimes in future I begin to focus more on regulation and all of that about AI, because we cannot joke with these things. People's lives are being destroyed. People's opportunities are being wasted just because of this. And I'll go to this again. So it might seem long, but I'm trying to just prep your mind on the reason it is important for us to have these discussions in the AI and data space. This is a very popular case where Amazon was shown to be biased to women in their recruitment system. Automatically, women were deemed more fit for certain roles than men. And this, also in healthcare, this was in cancer detection, where they realized that this solution for cancer in women was not very fitted for women in color. So again, we have the compass algorithm. And now at this point, I understand that we need to start asking ourselves, okay, why does this matter? Why are people talking about this? If we were here on Monday, you attended John Sanders' workshop where he gave practical solution, like a tutorial on how to implement, on how to build fairness-aware models. And when you look around, you realize that more people are looking at fairness, ethical considerations in AI, and it is very easy. AI is shaping lives. A decision a system makes can actually make or mar you. Imagine a case where you are in dire need of financial assistance and you need to apply for a loan, and your response to the loan is decided by a system that for no reason just flags you not capable of paying back because of bias. We've seen jobs and career paths where an AI system decides who is fit for promotion, who is fit for hiring, just like the Amazon system. And healthcare, criminal justice, just like in the Compass case study, where they were trying to use the Compass algorithm to look at which criminal is more likely to offend, so they'll decide when to either reduce their terms, increase their terms, and all of that. So this leads to we asking ourselves, what is the core problem? Why is this happening? The first problem, and the most foundational problem, is bias in the data and design. I know majority of us have worked on building models, and whatever a model fills out is based on what you give it in the training data. It's like a garbage in, garbage out before you start tweaking some parameters and all of that. In your data sets, in your model design, when you already have existing biases, it is automatic, your model becomes biased. So we need to be more intentional about the process of data creation, data collection, model design, and data documentation. This leads us to the problem of existing societal inequalities. When we talk about bias in data, most times we collect data based on real life happenings of people. And when we already have inequalities in the society, when you feel women are better for these positions, men are better for these positions, it fits into the data and creates like a negative loop, which eventually leads to discriminatory outcomes, negatively affecting the lives of people. Again, this is a very important discussion that needs to be held. Now, I want us to consider the following key questions. For a lot of people, they feel, why do I need to think fairness? My product is just it's just for a few people. I'm just a startup. My focus is trying to get my business running. Why should I think fairness? So let's ask ourselves these questions. First, does your use case or product specifically use any of these following biometrics? That's race, skin, color, religion, sexual orientation, status, income, country, and all of this. Next, Does your use case or product use data that is likely to be highly correlated with any of these listed above? Because we've seen cases where, for example, in the Apple case, when they went back to the CEO, they said, no, there was no gender fed into the training of the model. So how would you justify that our model is biased towards women? But sometimes, even though you are not collecting that particular data, you are collecting a data that is similar or fits in to the GDPR data you are meant to collect. So if you are doing any of this, ask yourself. Then the next is, could your case or product negatively impact individuals' economic or other important life opportunities, such as healthcare, education, access to a better life? Now, if your answer to any of these questions is yes, it means you need to start thinking fairness, you need to start thinking equity, you need to start thinking equality. This was sourced from cloud.google.com. So we go into what is bias. For me, I think the definition of bias is not something that is very straightforward. For one, bias might mean this to this person and another to somebody, but generally, I would describe bias as unfair outcome from AI decisions, usually caused by unintentionally encoding societal issues in models. Now, trust me, most times bias is unintentional. I'm sure no one is sitting somewhere and trying to build a product that intentionally discriminates against a set of people. Most times, it just comes maybe in the data collection stage or the model processing, or even at times, you build a very fair model, and at the end of the day, bias creeps back in because of the negative loop from consumers' interaction with the model. And sources are data bias, historical bias, sampling bias, and measurement bias. Once you sort your data, we can all agree that the data is one of the most crucial parts in building a model, because we go through rigorous process of data cleaning, making sure your data is high quality, because high data quality gives you good performing model. So if your data is biased, definitely you are producing a biased model. And historical bias stems from history. In Amazon's case, because more men were applying for certain roles, the model began to optimize the CVs for men better than women. So this is just based on history, what has been happening. And sometimes this affects individual outcome, because history says this person can do this better than this, but it is not always true in that case. Then there's sampling bias. For sampling bias, this occurs during either undersampling or oversampling, when you're collecting data sets for model training, and unconsciously you collect more data for a particular group of people, say 30% women, 70% female, or in healthcare systems where you collect, say, data for 70% white people, 30% people of color, then problems would arise. Then we also have measurement bias and algorithm and interaction bias. Algorithmic bias comes where you are trying to optimize your model for better accuracy. Where what's okay. Okay, it's back. So algorithmic bias happens when, during the model training, where you're trying to optimize either accuracy, precision, you are trying to arrive at a certain goal, and unintentionally you feed bias into the system. While interaction bias occurs when people interact with the model and there's a negative feedback back into the system. Now, sources and consequences of bias. So what kind of biases can exist in data? Like I mentioned earlier, it could be in the distribution and it could be in the representation. When you talk about representation, it means when you're collecting data from people and the data you're collecting does not suit into how they want to be described. For example, you're training a model for a product that will be used on children, but the features you are using to train your model does not accurately describe how the children want to be seen. Eventually, your product will not work for children. Then we have biased labels. This happens when you have annotators, which can be humans or machines. And the way to control this is by setting guidelines for your annotators. You have thresholds. When you see this, this is what is meant to happen. Or when you see this, you assign this to this. Because unconsciously, humans have some kind of bias that they do not plan to. And when doing annotation, you allow people annotate free-mindedly. You just realize that they create biased labels which will be fed into the system. And the consequences, repeating the consequences is actually not a mistake. It's just for us to reinforce what could happen when something goes wrong, as listed here. Now, fairness in AI, key concepts. So when you are trying to build a fair model, there are two things you have to keep in mind. The first is group fairness, and the second is individual fairness. For group fairness, you want equal outcomes between groups. Let's say you want same number of positions for women, say 50-50, or you want same number of outcomes for race or an age. In this case, each group receives positive outcomes at equal rates, and their true positive across all groups is similar. So you want the case of correct identification to be similar across all groups. And you also want the case of false negative to be similar across all groups. The major reason for this is to avoid systematic bias against groups of people. Going to individual fairness, this is just to ensure that people with relevant experience, relevant features, and relevant characteristics receive similar algorithmic outcomes. So you want the same outcome for myself, yourself, another person, once we have the same strengths without considering if you are a man or a woman. Now, this is very complex because sometimes you have an issue between choosing what to optimize on either group fairness or individual fairness, because sometimes when you optimize on individual fairness, you realize that a group of people might be left behind. And I know in most places we like to have either a gender-biased workplace or we like to have a gender-balanced workplace or anything. So when you optimize individual fairness, you are ensuring that everybody that is applying for that solution, regardless of their race or their gender, once they have similar characteristics, they get consistency. Now, what are the limits of fairness metrics? In as much as this has become a very strong conversation amongst people in the AI and data space, there are so many limits of fairness metrics. And the first is there's no universal fairness. Like I said, it is very difficult to define what fairness is. A decision that might be fair to me might be unfair to you. So at that point, it begins to stand between making an ethical decision versus making a technical decision. So there are some times that stakeholders need to meet to look at the goal they are trying to achieve and look at the demography they are trying to look at before they define, okay, for our use case, this is what should be fairness. Then we have, going back to conflicting definitions. For example, I'll go to trade-offs required. For trade-offs required, most times you have to drop you have to drop accuracy, precision, or privacy because you're trying to optimize fairness. When you've built a perfect model, but during the model testing, you realize that, it seems this group of people are not getting as much outcome as you would want to get. For example, say in the Amazon case where you see it's like a 90-10% or a 80-20%, the margin becomes too large, even though your model feels accurate. And at that point, you need to start optimizing fairness and dropping off accuracy and precision, which could be a very big issue when you're building models. Then we have reliance on sensitive attributes. Just like the current amendment of the EU AI Act, where you are now allowed to collect private data if it will help you build fair models, you begin to ask yourself, do you really need to collect the gender of people? Is it relevant to your product? Do you really need to collect the disability status of people? But sometimes when you are trying to optimize fairness in your models, you see that you need to start collecting data that might seem private to people. Another issue is simplification of identity. Sometimes we see models recognizing just men or just women, but we know that it is not as simple as that. I might be a biological male and feel like I want to identify as non-binary, or I want to identify as a female. Same with sexual characteristics of people. We have choices to make. And when you simplify identities to just male or female, at the end, you realize that you are building a model that is biased towards that underrepresented set of people. Another very key issue is intersectionality challenge. Now, we have cases where models have generally been good to either men or women. But what happens to Black women? What happens to Black men? For example, I read a case study where in a credit application case, the model was very good to Black women, but for Black men, it was in shambles. So sometimes there is this intersectionality challenge where what happens, rather than just using male, female, what happens if I'm a disabled Black female? There becomes a problem. And then we have fairness gerrymandering, which is as a result of intersectionality challenge, where the model is just good to a more recognized set of people. Now, another limit of fairness metrics is that there's no one-size-fits-all approach. It depends on your case study. If you are building a fairness metric for an healthcare system, you want to optimize true positives. You want to optimize when they are testing for, say, cancer, the scan has to be true positive. But when you are building fairness metric for the justice system, you want to be sure that you're not saying a reoffender is not likely to reoffend when he's more likely to reoffend. So there are varying arms depending on your use case and your sector. And then we have ethical customization. Now, I just have a line of thoughts there where I put fairness is complex and it requires careful thoughts and often compromises, which means there's no perfect solution. You just choose whatever aligns with your goals and values, which is the reason for any project you're embarking on, it is essential to set your goals and your values. So whatever metric you'll be setting has to align properly with your goal and values. Now, a holistic approach is essential. From what we've been talking about, from the build-up, we've seen that bias can come in at any point. It could be during data collection, it could be during model creation, it could be during system rollouts, and it could be during when there's interaction with the model, which means any approach as a data scientist or machine learning engineer would be taking must consider from the data collection part to the end, which is the model evaluation. So in summary, when you have better data, you have a fair algorithm, and you consistently audit your results, we have our fair model. Now, this is just an overview of mitigation strategies. First, you have to ensure that the data used for training is balanced and inclusive from the outset. This is something that I've mentioned earlier. You have to be sure that you are collecting, based on your use case, you have to be ensured you are collecting data for every group of people, and you have to be sure that the model is able to correct bias during training. This is where we bring in fairness-aware model, just such as the Fairlearn model or Google AutoML. Then we have post-training corrections, and we have continuous evaluation, which for me, I think is one of the most important parts, because oftentimes people focus on your data. Majorly, our focus is on the data. Then we move to the algorithm, and at the end, you are confident that, oh, I've deployed a fair model, but at the end, after interaction, there's a negative loop that feeds back into the system, and if you do not continuously evaluate your model, you realize that a once fair model becomes an unfair one. Now, best practices for creating diverse training data. The first thing is ask yourself, who do you need to include? When you are creating goals for your projects, it is very essential to ask that key question: who does this project affect? That makes you start thinking who you need to include. If you are building an healthcare solution for women, you should understand that you are thinking of building in your data collection, you are intentionally collecting data from even the more minority groups, because majorly the focus is on either African women, white women, and there are some minor groups that are often neglected, which is when bias comes in majorly. And I'll say they are mostly affected. That's the edge cases and minorities. And it is very important to consider real-world context. Real-world context means taking yourself off that bubble of what is happening in the room, in the design, and start to think of what happens when your product is used by the society. When you take that into consideration, it affects how you collect your data. Then we have documentation. For me, I feel documentation is a big one, because you need to document the source of your data. Where is your data coming from? What measures were used to collect the data? Was there any data cleaning that happened during the data collection? When each step is documented and you realize an unfairness at the end, it is easy for you to track back to know where that error came in from. So when you document every step during your data collection, it makes correction easier. Then you have the case of consent and privacy. Just like in GDPR rules, it is very essential that you seek consent of whoever you're collecting data from. And now, what do we watch out for? You watch out for proxy bias. What would you call proxy bias? It's saying, oh, I'm not concerned about where you are from because I'm not collecting your location. But you're collecting my postcode. Even though you're not collecting the country I'm from, you are collecting the area I reside in. And we all know that there are cases where we already know, if you check this area, this particular group of people lives here. So even though you are not collecting address, or you are not collecting, even though you are not collecting my ethnicity, just by collecting maybe a postcode that you think is not too serious, unintentionally, you are collecting my info by proxy. Then you need to check for historical bias. After collecting your data, it is essential to review your data, which could be through maybe exploratory data analysis. Then you check in your data, is there any historical bias? Is there any thought that has been re-echoing in people's mind that might be wrong, that has been unknowingly fed into your data? And then you need to question default labels. Sometimes when you ask for people, gender, male, female, or I don't want to disclose, when you fill that in your model, you see you have a lot of missing values for gender. Sometimes you might want to fill in by saying, okay, what do you think should come here? And you just label them. I think this person is male. I think this person is female. And eventually you are unintentionally feeding with bias. So this is a summary of everything I've said, the measures you should take during the data stage before training, during the model stage, and during the deployment stage. Again, reweight, resample, anonymize your data. Then during the model training, you have to put fairness constraints such as equal opportunity or demographic parity, which is dependent on whatever solution you are trying to build or whatever group of people you are interacting with. We have fair representation learning as well, and we have evaluation stage after training. Moving on to policy and global trends, the EU AI Act. Everyone has been talking about the EU AI Act, and this is just a summary in relation to what we are talking about today. Once your system is classified as high risk, you are subjected to strict regulation. And what do you call high risk system? Any system that has the ability to affect the lives of people, either employment, education, healthcare, where if anything goes wrong, it's possible for a risk to the person. That's labeled high risk, and those models are subjected to stricter regulation. Then we also have the mandatory dataset quality and bias checks. So according to the EU AI Act, it is very important for data analysts and data scientists to examine training, validation, and text data sets. You need to check for gaps, and you need to check for bias. Also, in specific contexts, like I mentioned earlier, it is possible for companies to collect and use sensitive data. So sometimes it might not be very necessary to collect that data, but because of the interest in avoiding bias, you are allowed to collect that data even if it is restricted under GDPR. Then we have transparency and documentation, like I mentioned earlier. It is very important for you to give a comprehensive technical documentation, which includes data origin, quality control, then the post-deployment oversight. Quickly going into the UK approach. The UK approach is more principle-driven, and it focuses on sectoral regulation. So finance is regulated by financial regulators and all of that. This is just to improve public trust on our models. Then my final word is bias isn't just a technical debt, it's a moral debt. It's not just an obligation because you want to be a very good data scientist, but because of morality, because of the effect of bias on the lives of people, it is essential for us to build fair models. Thank you.